Please, we're gonna get started. I hope this video is, it's augers, yeah. Okay, good. I think it's visible. All right, guys. So, the thought process that I would suggest on these questions, this isn't the only way to do them, of course. There's a lot of ways you could reason out the answer to this question, but what I think is maybe the simplest is to look at the graph, and I start by identifying just one key feature of the graph. So who wants to throw something out as like a key feature of this graph? Alyssa. Are you talking about the end behavior? Yes. Okay. That's getting a little advanced, but that's okay. We go to the end behavior. I don't want to shoot you down here, but there's an easier thing to look at than end behavior. That's usually kind of the last thing I might look at. Jaden, you got an answer? Very good. Yeah. So that's, I think, probably the easiest thing to look at. So this thing's got two vertical asymptotes. However, look at the answer choices. Only 3 of the answer choices up there would have two vertical asymptotes. So which half can I cross out? All the left ones. So A, C, and E have to be wrong. Let's pause there. A thoughtful pause, if you will. How come I know so quickly that those, I didn't read them that thoroughly, but I know that all 3 of them would only have a single vertical asymptote at +1, right? If I plugged in -1 in there, I would have -2 squared on bottom. That's not 0. Cool beans? Okay. Before I forget, the other class whined/convinced me to get a note card on this test. So you can bring one note card if you want with some notes. Things like, I don't know, how do I determine the vertical asymptotes of a function? You figure out what x values make the bottom equal to 0. So you can, I'm not thrilled about the note card thing because ideally, I'd like you guys to leave this class with, this is pretty fundamental stuff about functions, how they work.
You don't live in a perfect world.
No, the world is not a perfect world. That's correct. So you can have one note card with some notes jotted down on it to help you through the process. If you can do it without a note card, great. I would suggest trying to do it. Okay, we got that. So if you're taking the quiz tomorrow, I would just take some scratch paper and jot down just real quick for each question like this: A, B, C, D, E, F. Because for me, my memory is not strong enough to keep it all in my head. I'd probably have to I'd have to like that just so I can keep track of which ones I eliminated. Okay, let's get something else. There's one more thing we could look at that's going to unlock it for us in one step. Who's got an idea? AJ. The y-intercept. Yeah, that's a good way to do it. This guy has a y-intercept of 0, 1. But wait a second. D and F, if I were to plug 0 into those functions, they would spit out 0 as the y value. So therefore, those have to be wrong. The answer must be B. B as in B. Very important animal. Boggers, exactly. B as in boggers. Yes.
That felt like it hurt. It really did. It was very painful.
All right, next one. Same process. Someone throw out something we might look at on this function, a key feature of the graph. Not AJ. As much as I appreciate your answers, my friend. Eddie.
There's a vertical asymptote at x = 1.
Yep. And there's also not a vertical asymptote at -1. So which half of the answers can I cross out?
Right.
All the ones on the right. B, D, and F, I can cross those out. Oh my goodness. How do you guys feel about that, this process?
Good.
Make sense? Okay, so let's look at something else. We could look at maybe this x-intercept. It's passing through the origin, which means that if I plug in 0 for my x, 0 has to be my y, which means I can now rule out choice A. Let's rule out that. And then lastly, this one's maybe a little tricky, but because they're so similar. But It's C because look at the end behavior. What am I approaching on this graph? Approaching 0, but what would E has x squared over x squared end behavior. So that would be approaching 1. That's not correct. So we know that the answer has to be C. How do we feel about that? Cool, beans. Number 3. Let's see. Key feature.
You have 2 vertical asymptotes.
Okay, there's 2 vertical asymptotes, which means I can cross out.
Right
Right,
side.
the right
It's right down
The
there.
same side across.
And E.
And E.
Are we sure there's no questions on that principle? Positive. 100% A. Okay.
Here to
All right.
as well.
Yeah, these guys would only have vertical asymptotes at 1. Our graph has 2 vertical asymptotes. And then we say, well, I'm hitting the origin. By the way, I mean, E, I guess, is weird too. There's just an x plus 1 on the bottom. What's he doing? And then the fact that we cross the origin tells us that the answer is C. Because look at the top, right?
Yeah.
This guy, I look at the top and say, where would that guy cross the x-axis? No.
Don't.
Where would that? It doesn't. No. Okay, so let's review that then. So guys, if you have 1 over x squared minus 1, and you ask the question, does this guy cross the x-axis? You ask the question, then can I make the top of that fraction equal to 0?
No.
Is there anything you can do that makes 1 equal to 0? No, there is not. So that guy cannot cross the x-axis. The answer has to be C. C as in caterpillar.
As in
Coggers, yeah.
No, we're gonna do this for every letter. Yeah. Haven't decided on A and E yet, though. Augers? Eggers? Ogres?
Who was that I ran into the other day? And a bunch of people were sitting in the back of a pickup truck looking at their cell phones sideways. And I was like, what are you doing in there? You were in there. Oh, yes. That's what it was. It was some track guys or cross country guys.
They're playing.
You're playing
Guaranteed.
COD. Like we're CODing. Is that what you were playing? Or were you playing Clash of Clans? It was a very bizarre sight to behold. It was like 6 dudes all sitting in the back of a pickup truck then. Okay.
They were playing.
It would have been, I was hoping you guys were all playing in the same game. Maybe some Fall Guys or something. But anyway, I'm nationally ranked in Fall Guys, by the way. Number 4, Foggers. Key feature of this graph. He's only got 1 vertical asymptote. Ooh, so that combined, yeah, you could take those 2 facts and be like, well, only 1 vertical asymptote, so I can cross out these guys. And he's bouncing off the origin, so that means it has to be E.
Whoa.
Because the guy that created, look at the top, the guy that created the 0 is x squared. That means it's going to bounce off. Let's say that's a little bit, hey, that's too sneaky for me. I want to think in simpler terms, sir. Okay, just do end behavior then. This graph doesn't seem to be approaching 0, does it? It seems to be approaching 1. And this graph here, choice E, has x squared over x squared end behavior. So does that agree? Yes, it does. So the answer is E. That's an elephant.
Eagers?
Eagers.
I'm going with Eagers.
Number 5. You guys get the idea, right?
Yeah.
They're not too scary, right?
Okay.
Who said eh? Who said, no, James. All right, James, you've asked for it. Give me a key feature of this graph that will help us eliminate some wrong answers.
2 vertical asymptotes.
Very good. So which half of the answers can we cross out?
The left side.
Very good. Boom, boom, boom. Let's see. Could I look at end behavior? Yeah, end behavior works because what value would B and D both be approaching? Mr. 0.
Yeah.
0.
I think some 0 has to.
Why is it happy?
Why wouldn't he be?
I don't know. I
There's
just-
nothing to worry about because there's no numbers. There's no value. Right? Yeah, zero's just chilling. Yeah.
What would you be happy if someone said your life has no value?
Yes. Yeah, I'd be Jay chilling. You okay?
Anyway, this, you have x squared over x squared, which we know, what is that going to approach? That's going to approach 1, which our graph appears to be doing. There's also the bouncy x-intercept. There's a few different ways you could reason this out, right?
Yes, sir.
All right.
This one was the funky.
You guys will stop me if there's questions, right?
Yes. I got
Right.
this one right.
Thanks, Han Banan. It's very reassuring. I've been doing this for a long time, and sometimes I go through this, and then someone goes, "Man, I had a lot of questions." Like, but I stopped like 20 times to ask if anyone had any questions. Okay, so number 6. This one, very weird. You might notice off the bat, there's only one vertical asymptote, so we can cross out
Left side.
the left ones. Those guys would all have 2 vertical asymptotes.
They're very right.
And then the end behavior is very strange. Where there's a diagonal asymptote, which means that there can't be, like, say, it's not approaching 0, it's not approaching 1.
One of us is gonna be cool.
Hello. Yes. Okie dokie. See ya. Peace out. So there's a problem with B. B has x over 2x. What would that approach?
That should approach 1/2.
Would approach 1/2, right?
Oh,
1x over 2x would be 1/2.
right.
So that's not what's happening in this graph, right? So it's either D or F. They have the right end behavior. There's one key difference though. F, how many times would F cross the x-axis? 2 times. He would cross at 1 and -1, right?
Yeah.
Obviously, that's not what's happening in the graph, so it's got to be choice D. Once again,
Joggers.
bouncy. That's pretty bouncy, right? X squared creates that bouncy x-intercept. All right. Poggers.
No, dog.
Joggers.
Dog can't.
What are we done for here?
Can't unplug it.
Okay.
We not done yet.
Notice the answer choices here. They all are showing 2 vertical asymptotes, and a mean man made them all weird looking. So the ones on the right have +1 and -2 as x-intercepts, and the ones on the left have -1 and +2 as x-intercepts. So which one is correct?
The left side is correct.
Yeah, the left ones, -1 and +2. So be extra careful, right? If it's like that, they, capital T, they are trying to get you to mix them up. But you guys remember Mr. Toadman, what he told you? You don't remember him?
I don't remember Toadman. I'm sorry.
Mr. Toadman.
Toadman. Everyone knows about Toadman.
This is what he tells you.
Oh, that's not a toad, that's a fish.
No.
That's a fish.
Admiral Akbar is a fish.
Where's my favorite video? Oh, I can't even find it. There it is. If you're ever considering selecting the wrong answer, this extends beyond math class. I mean,
It's a fish.
so think about Mr. Toadman. If you're ever, before you put the wrong answer, remember, it could be a trap. Okay?
How do I remember that guy's name? I
Yeah.
can't do this. Off the top of my head.
Anyway, what else could I look at?
And
Is that an x-intercept?
The x-intercept is 1. So what's the answer?
I mean, it's gotta be.
Oh,
A. So the vertical asymptotes, right? The vertical asymptotes are happening at x equals positive 2 and x equals negative 1. No, because yeah.
I know, yeah, okay, I got it.
You got it?
Because it's just two ways to be inverse.
And then we know things like another example of how you could get this one. C and E have the wrong end behavior. Their x-intercept is all wonky because this guy would have two x-intercepts. This guy would have a bouncing x-intercept. But even more simply than that, I think, is to look at the end behavior. C and E both have x squared over x squared end behavior. So they would approach 1.
Say vote backwards.
This guy is sad.
Yeah, he does.
Sad.
No voters.
he's very.
Okay. This guy has, again, 2 vertical asymptotes at positive 2 and negative 1. So again, that's the denominator I'm looking for. X plus 1 times x minus 2. But this guy doesn't do what?
Parabola, so he's E.
He does not cross the x-axis. Very good. Which means his top doesn't have any x's in it.
Too cool.
Do we feel okay about that?
Maybe that's why he's so sad.
All right. Number 9. This guy does not have any vertical asymptotes.
Nope.
Yeah, curvy dude.
None. 0.
So which half of the answers are wrong?
It's
Yeah. Any of the answers where the bottom could equal 0, like could that equal 0?
Yeah.
Sure, if x was negative 1, that would be 0. So these have to all be wrong. And then I just need to look at maybe like the x-intercept, because the x-intercept seems to be positive 1,
Does.
but only one of these answers would equal 0 if we were to plug in 1 into the function. Which one is it?
C.
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 Augers.
C.
Do you feel okay about that, guys?
Yes.
Why it's C?
C.
Og.
Where would these guys touch the x-axis? A and E would touch the x-axis where?
0.
0, 0, the origin.
Never.
The Y intersection.
All right. Here's where if you're having a hard time with this material, guys, this is where the note card will really help you. I mean, a note card will really help you on these a lot, but even more so on this. This is kind of why I was a little hesitant about the note card idea in the first place, because you really ought to know these kind of ones. Just know them. If you really want to understand, like, have a good grasp of this stuff. What do you got to do if you want to know the y-intercept of any function? Just plug in 0. No, you're thinking of x-intercepts. You plug it, to get the y-intercept, you just plug in 0. So let's plug in 0 into it. What's the top of the fraction if we plug in 0?
3, 6.
Positive 36. The bottom is negative 2. So what do? We plugged in 0 for our x, and our y value is negative 18. Are there any questions on that? Okay. This one's a little bit weirder. Which function below has no x-intercept and also no y-intercept? What do you guys think? Should I look for the no x-intercept first, or should I look for the no y-intercept first?
Look for no X first. They'll narrow it down more.
X is first. don't
You
think.
could, okay, there's no right answer to that question. It's a matter of opinion. But in my opinion, it's easier to look for this first. And the reason is that's a weird function. If you don't have a y-intercept, that means that your x value isn't allowed to be what number?
0.
0, right? Because that's how you find a y-intercept. You plug in 0. So if you don't have a y-intercept, then I guess x wasn't allowed to be 0. So only one of these pretty clearly, right? Can I plug in 0?
The ogres.
Can I plug in 0? Can I plug in 0? Can I plug in 0? Only E can you not plug in 0. Okay?
Yo.
Sure there's no questions here?
English is
I'm
weird.
positive.
Yeah.
Okay. But I mean, we can also confirm.
That's kind of funny.
There's no x-intercept because the top is just a 1. Okay. This function has 2 x-intercepts. Again, note card could help you big time here if you're having a hard time. How do I find my x-intercepts? What do I do?
Top equals
I'm looking at the top. I'm setting the top equal to 0. I'm saying, let's factor this. That would be x minus 2 times x plus 1. And I'm wondering what x values would make that equal to 0? 2
And 1.
and negative 1. Be extra careful on these ones, guys. It says select 2 answers and find both. And then there's all the other hint is there's little squares. If you only click 1, you don't get the point. So no, there's no half point.
0 points.
Sadly. You have to get it perfect. You gotta get it perfect.
0 points.
You don't believe in that? Okay. 2 vertical asymptotes. This time, we're looking at the bottom of the fraction. So you focus your attention on this. How could I make x squared minus 9 equal to 0? 3 or negative 3 would be our answer. Find a hole. There's Mr. Toadman on this one as well, so be careful.
It's a trap on this one. Square trap.
What do we do when we see stuff that looks like that usually?
You get stacked.
Factor. Okay. If you factor the top, 5x plus 5, x plus 1. On bottom, you got x plus 3, and x plus 1. There's 2 traps on this. There's 2 trickies. Well, first of all, we can eliminate half the, which half of the answers are clearly wrong? The left. No, it's asking for a hole. These ones are all right.
Yeah, sorry.
The hole is generated by the x value that created the 0 over 0. Okay, so negative 1 is our x value. Now, a lot of people, they're missing something. I don't know. They're missing a point here. They just go straight to this. E is wrong. Okay. That's actually been a mystery to me for quite a while. Why so many? It's actually a very common misconception that the y value of the whole is always 0. That couldn't be farther from the truth. That's definitely not the case. But what do I do with that negative 1? Where does it go?
Plug it into the new thing.
Yeah, I plug it into the simplified form. Okay. If I plug negative 1 in there, what do I get on top? And on bottom. So the y value is 2. So the whole on this graph is at negative 1, positive 2.
I really don't understand why, because that does not make it 0 over 0.
What? No. If it's 0, if you get a 0 over 0 with the original one, then it has a hole.
It does. You don't understand why negative 1 doesn't make the original function 0 over 0?
Oh, the ones that we crossed out.
Yeah, so I'm identifying that value by looking at what term got canceled out, right? So because negative 1 is the number that makes those 2 terms 0. And then where I plug it in is after I've so technically this function is the same as x plus 5 over x plus 3, comma, x can't be negative 1. But what I do is I go, well, I know x can't be negative 1 because it would be 0 over 0. But if I could plug in a number very close to negative 1, what would I get? Close to? And the answer to that question is you get simply by plugging that number in here. All right, so are we okay with that, guys? All right. Find the hole in this graph. Okay, same process. Factor the top. Factor the bottom. Here's another common mistake. This one I understand better, where this is coming from. A lot of people do this. Ready? Again, this is wrong. Be careful. Toady. They cross those out and then say, oh, it's x minus 4. No.
Sometimes your brain just skips over it.
Yeah, that's what I'm saying. That one I actually understand. Like, yeah, because you cross it out. And, I mean, I see it right there. It's right. But with the 0 thing, that one is a weird one that I can't really wrap my head around. I'm trying to.
Don't try.
Don't try.
Succeed.
You,
Just succeed.
Just succeed, yeah.
don't try. Just
understand.
If you're ever on the brink of failure, just succeed.
Of course.
stop.
That's how you gotta
Stop failing.
I never thought of it. Yeah.
Just win.
You're about to.
That's why I'm really good at basketball. Every time I'm about to miss a shot, I just don't miss it. I throw it in the hoop.
Yeah.
Then you get points.
So every shot you don't take,
You miss.
both miss
You
and
make 100% of the misses you don't miss. You make 100% of the misses that
You miss
don't
100%
you
of
don't
the shots you
make.
don't take.
You don't miss.
That's the original thing.
So
Yeah,
it's-
don't take the shot. You not have missed it. You made it.
Like with
Yeah,
baseball,
Schrodinger's
you go up to the plate, just hit it out of the park every time.
Schrodinger's shot.
Why do they always hit the ball into like?
It's
Yeah.
not.
Oh, why hit it into the ground? When you if you hit it over the
It's
fence,
not-
you get free runs.
yeah.
you don't
easy
have to
sport.
cut it all, but
Too
that's how
bad.
you open it.
Okay.
So therefore-
I do, I can hear him.
So what number
Simple.
do I have to plug into this?
Yeah, plug in.
4, negative.
I gotta plug in -4. If I plug -4 into that, so I'm plugging in -4. Now why? Because that's the term that got canceled out. And what do I get? I get 1 over -8. Okay? D.
Doggies.
Wait, how did you get negative 1?
Thing already. So after we factored and canceled out. That's okay. That's fine.
I'm keeping you on your toes.
Find the domain. Oh, what is domain?
All numbers x can be equal to.
Yeah, it's well, I usually find them by saying what numbers aren't allowed to go in, so I'm concerned with I can't divide by 0. So what x values would make that bottom, which I can factor into this, what make that expression equal to 0? Well, a 4 or a 3. So the answer is B. X can be anything except for 4 or 3. Are we cool with that?
Yes.
No.
Okay, this question says select 2 answers, 1 from A through D and 1 from E through H. So that's already kind of a hint. Because a lot of people, sometimes they look at this and go, oh, there's 2 asymptotes. Understandable mistake. They're mixing it up with something like that, right? But there's only 1 vertical asymptote. Where is it? At positive 1,
Bond.
right? Because that would cause us to be dividing by 0. Where's the horizontal asymptote? Now, why is that? Because the top has x, it's the only term. The bottom's dominant term would be x squared plus some junk, but what we really care about is that. That would approach 0. Bigger power on the bottom. Okay, C and F. You got to get them both. Be careful.
Oh, no.
These are tricky because the odds of guessing this correct, if you had no idea, would be 1 in 16. That's assuming you, because you have 4 choices and then 4 choices, so 4 times 4. There's 16 possible.
Yeah, that's true.
And that's assuming you did it correctly by clicking 1 from A through D and 1 from E through H. So just be careful. They're not going to be trick questions. They should be very straightforward. So this one, what's the vertical asymptote?
Vertical one. It's gotta be
2. The horizontal would be
gotta be 1.
1. We have x squared over x squared. End behavior. D, G. 2 more, guys, and we're done. What's the end behavior of this function? Notice there's 8 squares. You click one of these and then one of these. So as x goes to negative infinity. So think of this as left and right. Although I guess it doesn't really matter because look at the dominant terms. What is 6x to the 4th divided by 2x to the 4th?
3. X.
3. No, the X is ridiculous. So so the way this would look if you're doing it, if you're jotting down some algebra, would be, oh, this divided by this is 1. So I'm left with 6 divided by 2, no matter how large X is. 6 billion divided by 2 billion is 3. 6 trillion divided by 2 trillion is 3. So in both cases, we're going towards 3. D, not E, D, H. Yes, you guys.
You started something you can't undo.
Losing subscribers.
What is it?
It's got negative 500 bits.
That makes sense.
They're taking like.
What's our name? Talkers.
And behavior. One last time behavior. Okay. I have on top, I got x cubed, dominant term. On bottom, I have 2x.
That is,
Let's think about that.
well,
Well-
that's confusing.
Does it help if I think of x cubed as x squared times x?
That helps.
Yes.
X squared over 1.
X squared. So, by the way, could I rewrite this as 1/2 times x squared?
Yeah, this is gonna be pushing.
So what shape is that? It's a parabola. So this graph- Sure, there's wacky stuff happening for small x values, there's asymptotes and whatnot, but on the far ends, it has the same end behavior as a parabola. Right? So that means on the left and the right, it's approaching positive infinity. A.
I don't like that.
Yes, you do.
Yes, you do.
Let's submit. Did we get them all?
We better.
Oh, we did it, guys. Oh, amazing. Yay.
That's a
To the power of togetherness. Yay, we did
I
it.
think we learned a valuable lesson that we should use that for all of our tests.
What?
I think we learned a valuable lesson that we should use that for all of our tests.
Okay. Are there any more questions on
No.
your problem set's due tomorrow? So if you have questions on the problem set, we can go over those now.
Nope.
We've got a little bit of time.
None.
Shitty. No, you guys sure?
Yes.
All
I
right.
told you.
Cool beans.